All right, so let's go ahead and find the volume and surface area for this cone. Formula for the volume for a cone. Volume is equal to what? One-third. Yes, 1/3 pi times radius squared times the height. So let's go ahead and substitute in. What is the radius for this cone? 5. Nice work. Down there at the bottom, they're showing the diameter is 10 inches. And so the radius, each side of this, would be half of that 5 inches. So that's what we're going to put in for r. So 1/3 times pi times 5 squared times our height. What is our height? Height of 15. And then we take that and we pop it into our calculators. And what do we get for the volume of this particular cone?
Good morning, Pike High School. This is Mrs. Boland. This is a reminder for all AP students that are testing. You need your school ID card. Driver's license, state IDs, and phones will not work. You need your your school ID card. At this time, all AP English Lit students need to be dismissed to the main gym. All AP English Lit students need to be dismissed to the main gym. This afternoon, AP Computer Science A needs to report to the main gym at 11:30. AP Computer Science A needs to report to the main gym at 11:30. Thank you.
All right, so 392.699 inches cubed for our volume. Surface area. What's our formula for surface area? What'd you say? Yep, pi r squared. This is the area of the base. Plus pi r slant height. This is our lateral area. Let's find the area of the base first. So pi r squared, we know our radius is 5. So pi times 5 squared would give us what for the area of just that circular base there? 78.5. Let me glance at your calculator real quick. Yep, 539, so 5.4. Perfect. I thought that's what you were saying, but then I thought maybe I misheard it, so I just wanted to come over here and check with you. All right, so surface area. Our base is 78.54. And then our lateral area, pi times our radius of 5 times our slant height. Do we have the slant height for this cone? No, then we need to go in and find it. How do we find it? Pythagorean theorem. Awesome. Sir. So we'll do a squared plus b squared equals c squared. What are we putting in for a and for b? 5 and 15. Does it matter where I put the 5 or the 15? Nope. So 15 in for one of them, 5 in for the other. We're going to take both of these and square them. And that will be equal to my slant height squared. Here's my slant height. What is 15 squared? 225. What about 5 squared? 25. What happens when I add 225 and 25 together? We get 250. So 250 is equal to my slant height squared. And we're going to take a square root of both sides to cancel out the squared on my slant height. Is the square root of 250 a pretty number? No. So we're just going to leave this as radical 250 for the slant height. We're going to take that and substitute it in up here. Square root of 250. And then when we take that and put it into the calculator, pi times 5 times square root of 250, what do we get? 248.364. What comes after the 4? A 7. So my 7 is going to round my 4 up to a 5. So 248.365 for the lateral area. And then we have to add those two together for our total surface area. It gives me a total surface area of 326.905 inches squared. Very nicely done. Right. We are going to get into your notes next. Don't forget the spheres homework is due tomorrow. But in your notes on page 12, we're going to start looking at some composite figures. So composite solids are where we take two solids or more and we put them together to make a new solid object. Something like this. This looks a little bit like the second one on the page, like example number 2. Example number 1, we kind of have like this rocket ship shape. What two solids is this shape made up of? A cone and a cylinder. And because they've been put together, we are going to add their volumes and surface areas. All right, so let's see what it says about our cone and our cylinder. The diameter is 20. So that means from edge to edge on my circle, top and bottom base would have a length of 20. So what's my radius then? 10. Radius of 10 here. Same is true up here. We have a radius of 10 here because those two bases are congruent. The height of the cylinder is 8. So I'm going to add that to my picture. So from here down is 8. And then the height of the cone is 24. I keep finding the wrong color. Let's do this one. Height of the cone is 24. So from the vertex of the cone straight down to that radius, making a right angle with the radius, I have a height of 24. So far, so good? Awesome. What do we need to find about this solid? What did they ask us to find here? They asked us to find the volume and the surface area. Let's do one at a time. Let's do volume first because when we're doing composite figures, volume is going to be the easier one for us to calculate. So for volume, we're going to need to take the volume of the cone plus the volume of the cylinder. Order does not matter since we're adding them together. I could say volume of cylinder plus volume of cone or volume of cone plus volume of cylinder. To find the volume of the cylinder, what is our formula? Pi radius squared times the height. Plus, how do we find the volume of a cone? 1/3 pi radius squared times the height. Do the cone and the cylinder have the same radius? Yes. How big is the radius for both of those objects? 10. So pi times 10 squared. I'm going to leave a space for my height. I'm going to come over here to the cone, 1/3 times pi times 10 squared, and then we need to, of course, leave room for the height again. What is the height of the cylinder? 8. So that's what I'm going to put over here with my cylinder volume formula. And the height of the cone, 24. Let's do each of these separately on our calculator. Let's calculate the volume of the cylinder first. Pi times 10 squared times 8. You said 2513.27, and what comes after the 7? 4. Perfect. 2513.274 plus, now let's do the same thing, but this time for the volume of the cone. 1/3 times pi times 10 squared times 24. 2513.274. By chance, we got the same thing twice. They had different heights, and that's part of why they came out to be the same, because one of them has that 1/3, the other one doesn't. But they did come out to be the exact same number. So now we're going to combine these two together to get our total volume. I get 5026.548. Do we have units with that? No. So we're going to put units cubed. 5026.548 units cubed. Beautiful. Now, surface area. This one's a little bit more complicated than our volume. When we say surface area, I want only the area of the things that would be exposed to the air. If it would not be exposed to the air, if it would be covered up, I don't want to include that in my surface area. We're going to need the height. We're still looking at surface area of cylinder plus surface area of cone. What's my surface area formula for a cylinder? Two pi r times height plus 2 pi r squared. Which of those pieces is the lateral area? The first part or the second part? First part is my lateral area. This 2 pi RH. There's my lateral. Which means 2 pi r squared is my two bases. Are both of the bases here exposed to the air? Would they be covered with paint if I was going to paint this object? Are any of the bases on the surface of this object? One of them, the bottom. Like if I were to paint this whole object, I would paint the bottom. I'm not going to paint the top of the cylinder because that's glued to the bottom of the cone. So do I need both bases? No. Only one base. All right. Now let's do surface area for the cone. What's our surface area formula for a cone? pi r times the slant height plus pi r squared. Which of those pieces is the lateral area for the cone? First part, pi r slant height. This is my lateral area. And so this is my base. Do we want to include the base of the cone in our surface area? Would it be covered with paint if I were to paint this object? Is the base of the cone on the outside of my figure? No, so we are not going to include this part. Base of the cone is on top of the cylinder. All right, so far so good. Let's go ahead and substitute in what we know, and if there's something that we don't know, we'll find it along the way. All right, so I have 2 pi times radius, and I'm on the cylinder right now. What is the radius of the cylinder? 10 times the height of the cylinder, 8. Plus, and we crossed out the 2 because I don't want 2 bases, I just want the one base, the one on the bottom, pi r squared, so I have pi times 10 squared plus pi times my radius of 10 times the slant height of the cone. Do I have that part? No. So we're going to have to go and find the slant height of the cone. How do we find the slant height of the cone? Pythagorean theorem. And I'm only going to use numbers from the cone here. So a squared plus b squared equals c squared. What goes in for c? The slant height. That's the hypotenuse of that right triangle there inside my cone. And so for a and for b, 24 and 10. Doesn't matter which goes where. So I'm going to put 24 in for one of them and 10 in for the other. We're going to take those and square them. 24 squared plus 10 squared. What is 24 squared? 576 plus 10 squared? 100 equals slant height squared. So 676 equals my slant height squared. And then I'm going to do a square root of both sides. Does the square root of 676 come out pretty? 26. So 26 for my slant height. So we're going to go substitute that in now. All right, let's do these each one piece at a time. We're going to separate it by the plus signs. Let's do 2 pi times 10 times 8 first. 2 pi times 10 times 8. 502.65. Give me one more decimal place. 4 and is an 8 comes after that, so that's going to round my 4 up to another 5. So 502.655 plus pi times 10 squared $314. You said 0.159? 159 plus, now let's do the lateral area for the cone. Pi times 10 times 26. $816.814. Before we add all those together, I want to make sure that we can identify what all of this is. This is the lateral area of the cylinder. This is one base of the cylinder. My bottom base. And this last piece is the lateral area of the cone. So now we're going to add those three numbers together to get our total surface area. What is the total surface area for this object? 1633, you said 0.628? 0.628 units squared. Nicely done. Very nicely done. All right, let's see if we can get to one more example today. The next object is made up of what two familiar solids? A cube, and I didn't hear the other one? A pyramid, yes. The cube is a prism. It's a special kind of prism. What's true about all the edges on a cube? They're all the same. They're all congruent. So this is a rectangular prism with all edges congruent. And that's what the bottom of this object is. On top of that, we have what shape? A pyramid. All right, let's figure out what we know about this cube and this pyramid. It says base edge is 16. Base edge is 16. So everything on my cube, that means length, width, and height, are all 16. Because it is a cube. And height of the pyramid is 15. So going from the vertex down to the very center of the pyramid, right about here, coming down from the top, and it makes a right angle when it gets there. This is 15. So far, so good? All right. Volume and surface area here. I like starting off with volume first because I can just grab the formulas and plug in. I don't have to worry about which pieces are covered, which pieces aren't covered. Do I have to include all the bases? I just use the volume formula for both of my objects, and then I add them together. So volume. We are going to need the volume for the cube plus the volume for the pyramid. How will we find the volume of the cube? What did we say a cube was? It's a rectangular prism. How do we find volume for a prism? Area of the base, so big capital B, times the height. Plus volume for the pyramid. How do we find volume for a pyramid? 1/3 area of the base times the height. What shape is the base of the cube? A square. because it's got all congruent sides, 16, 16, 16, and 16 in the back there. How do we find the area of a square? Side squared. So I have side squared times the height plus 1/3 area of the base of the pyramid. What shape is the base of the pyramid? Also a square, because it's sitting flatly on top of our cube, times the height of our pyramid. And now we're going to start plugging in our numbers. How big is the side of the cube? 16. So I'm going to have 16 squared times the height of the cube. What is the height of the cube? Also 16. Plus 1/3 side length of the base of the pyramid. 16. So 16 squared times the height of the pyramid. 15. All right, let's do this one piece at a time. Let's find the volume of the cube first. 16 squared times 16, or that would be the same as 16 cubed. (16 squared times 16). What do we get? 4,096. Plus, now let's find the volume of the pyramid. 1/3 times 16 squared times 15. $1,280. So we have the volume of the cube and the volume of the pyramid. We're going to add those two together to get the volume of this entire solid object. And that'll give me 5,376. Is that right? And should we put units with that? Units cubed. All right, now our surface area. We need surface area of the cube plus surface area of the pyramid. What is my formula for the surface area of the cube or a rectangular prism? I think you're looking at a cone. We want rectangular prisms because a cube is a rectangular prism. Two times the area of the base plus the perimeter times the height of the cube plus, and now we want surface area for the pyramid. Yes, area of the base plus 1/2 times the perimeter times the slant height. All right, let's look at all these pieces. Are both bases of the cube on the surface of this object, on the outside of this object? Are any of the bases of the cube on the outside? One of them is. So we're going to get rid of the 2 out in front. Only one base. The other is covered by the pyramid. Do we need the entire lateral area of the cube? Do we need all the sides of the cube? Yes. We need all of this space here. We have the base on the bottom. We have this space here. But we don't need the top base. So we need all of the lateral area. Do we need the base of the pyramid? Is the base of the pyramid on the surface of the object? No. No base. It is on top of the cube. Do we need the lateral area for the pyramid? Yes, we need all the little triangles. So we need this part. All right. Let's see what we can do with this now. That big capital B means area of the base, and we're looking at our cube. What shape did you tell me that base was? It's a square. And how do we find the area of a square? Side squared. Plus the perimeter of the base times the height of the base. Plus, we leave out the base of the pyramid. We have 1/2 perimeter of the base of the pyramid times the slant height of the pyramid. All right, what are we putting in for S here? That's the length of the side of my cube. 16. We want the length of the side of the cube to go in for S. So 16 squared plus, now I need the perimeter of the base. What is the perimeter of the base of the cube? 64. How'd you get it? 16 times 4 gives us 64. So we're going to put 64 in the place of P over here. And then what is the height of the cube? 16. So 64 times 16 gives me my lateral area on the cube. Okay, go back and grab it then, thank you. Plus 1/2 times the perimeter of the base of the pyramid. What is the perimeter of the base of the pyramid? What is the perimeter of the base of the pyramid? What shape is the base of the pyramid? It's a square. It's 64 again. Why? Because it's the same as my cube. I have 4 congruent sides on the base of the pyramid. Each of those sides is 16. So I have a perimeter of 64 there as well. Times the slant height of the pyramid. Do we have that? No. So we're going to have to come up here and figure this out. I know the height is 15, and that's all I know. Here, coming down this lateral face, that is the slant height that I'm wanting. What other piece do I need if I'm going to calculate the slant height? I need the distance from here to the edge. That's like the apothem on a regular polygon. Because the base of this is a square, how big would that length be right there? 8. It's going to be half of my base edge. Do I have enough now that I can use Pythagorean theorem to find that slant height? Yes, awesome. So Pythagorean theorem here, a squared plus b squared equals c squared. What goes in for c? Slant height. So slant height squared goes in for c. What goes in for a and b? 15 and 8, yes. Thank you. So 15 in for one of them, 8 in for the other. We're going to take them both and square them. What is 15 squared? 225. And 8 squared? 64. So 225 plus 64, which is 289, equals my slant height squared. Then we're going to square root both sides. 17. We get a nice whole number there for our slant height. Doesn't happen very often, but it's nice when it does. So there's my slant height. All right, let's calculate each of these pieces separately, and then we will add them together. Let's do 16 squared first. What is 16 squared? 256. Plus, now we do 64 times 16, 1024. Plus, and now we do 1/2 times 64 times 17. 544. So just like we did on the last one, I want to make sure that we can label what all these pieces are so we know where they're all coming from. And then we're going to add them together to get our final answer. So this is the area of one base, the bottom of the cube. Right here in the middle, this is the lateral area of the cube. And this 544 over here is the lateral area of the pyramid. When you're doing these problems for me, you do not have to label those pieces, but I am going to be asking as we're going through especially surface area stuff, where these different numbers are coming from, what they correspond to on the picture. What would our total surface area be for this object? 1,824 units squared. Very, very nice work. That is where we're going to stop for today. Tomorrow we'll keep practicing with some composite figures. Also, your spheres homework is due tomorrow. That had 7 or 8 problems front side only, using only the formulas that we learned yesterday.